5.5, we're going to talk about amplitude and period. So first of all, a couple definitions. Let's start with the second one actually. I should have written that first. Periodic functions. A periodic function is a function whose graph repeats in regular intervals or cycles. So I've actually drawn a couple periodic functions down here. You see how it repeats over and over and over? You've got this same shape, this TP shape over and over and over, or you've got this same curvy shape over and over and over. So those are periodic functions, and we've already seen those. Where have we seen periodic functions so far? We've seen them just last day with our sine graphs and our cosine graphs. So what sinusoidal functions are, they're a type of periodic function. They're a type of periodic function whose graph has the same shape as that of y equals sine x. So if you recall from last day, the way that that graph looked like, the y equals sine x graph, is it looks something like this. Up and down and up and down and up and down. So both of these are periodic. Is this first one sinusoidal? No, it's not. It doesn't have that shape. I mean, it kind of does, except there's no peaks, right? There's no sharp peaks in the sine graph, so that's not sinusoidal. Is this one sinusoidal? I have to admit, I would say no. Maybe I'm wrong, but I think I would say no because I think it has to be a regular, same height, same trough, same height, same trough, like that. This one varies, obviously. It goes this high and then it goes this high. So I think the answer is no. I might actually be wrong. Someone figure that out for us. So what we did last day is we looked at this, y equals sine x. Now what we're going to do is we're going to look at this, y equals a sine bx plus c plus d. Wow, we're going to add some numbers. These, the a, the b, the c, and the d position, we're going to put numbers in there, and we're going to see that how that impacts the sine graph. So today what we're going to look at is what impact the a value has and what impact the b value has. We'll deal with c and d next day. So to start, we're going to define two more words, and these are the words that give us the title, amplitude and period, so you know they're pretty important. What the period is, it's the length of the interval of the domain to complete one cycle. So basically what that means is how long does it take for the cycle to start over again. So if we look at this red periodic function here, you can pick any point you want. Usually I would pick either a minimum point or a maximum point. Let's go with the maximum point right here. And where does this periodic function start repeating? It starts repeating again right there because there's another maximum point. So the period is basically this distance from here to here. How long does it take for it to start repeating? Well, here's 1 right here, so I guess this is 2, I guess this is 3, I guess this is 4. The amount of distance, or the length of the interval of the domain until it starts repeating, is 4. So the period of this is 4. Okay, let's try this one. Again, why don't we take that same point, the maximum right here on the y-axis. Now, should we go to here? No, that's not the end of the period. The period in this case, it goes down, it comes up a little bit, goes back down, then goes back up a lot, back to the starting point. This is the starting point up there, right? So the period is this distance from here to here. So what's that distance? The distance is 6. Alright, on to amplitude. So what amplitude is, it's the distance from the midline to either the maximum or the minimum value. And it's always positive. The reason it's positive is because we're talking about distances, and distances are positive. Okay, so the distance from the midline, what's the midline? Well, kind of just like it sounds like, a midline is the middle point of a periodic function, right? It's like a mirror line. Where could you put a line that would cut this thing in half perfectly? Now I know you could actually cut it this way or here, but it's talking about in this direction. This is the midline right here. So what the amplitude is equal to is the distance from this midline either up to the highest point, either there or there or there, it makes no difference, or from the midpoint down to the lowest point. Again, it makes no difference where you look. Because the distance from here to here is, oh, how much is that? I guess if this is 1 and this is 2 and this is 3, I guess this is at about, what, 1.5? And same if you look here, it goes down to this point, and this point here is at right around 1.5. So our amplitude is 1.5. Now there's actually a formula you can use to figure out amplitude. I'll give it to you. It's not always necessary to use. Here it is. The amplitude is equal to the maximum amount, take away the minimum amount, divided by 2. So I'll just show you that here. What's the maximum amount here? Well, we already said the maximum amount is 1.5. What's the minimum amount? It's negative 1.5. And what that formula said to do is take the maximum, subtract the minimum, and divide by 2. 1.5 take away negative 1.5, it's the same as adding. You get 3 over 2, and 3 over 2 equals 1.5. Okay? Alright, the amplitude of this one. Now again, I might be messing up here. I really wish I hadn't put this this function on the video, because it might be making myself look like a fool. But I'm not totally positive whether this one has an amplitude, because it might be the case that it has to be a regular, it has to be the same, but I don't think so. The definition of amplitude is from the maximum to the minimum divided by 2, or from the midline. It's not really a midline though in this one. That's the problem. There's no midline. Well, let's go for it anyway, and we can use this formula here, because the maximum amount is right here. How much is that? Here's another reason I wish I hadn't picked this one. I guess this is 1 and this is 3, so I guess that's 2.5. What's the minimum amount? Well, this must be negative 1, so the minimum must be at negative 0.5. So you're going to subtract negative 0.5 and divide by 2. So that equals 2.5 plus 0.5, which is 3 over 2. You get 1.5. Hey, we got the same amplitude in both cases. Alright, don't show your friends and family this one, because I'm not sure how many mistakes I've made in that one. But hopefully you get the idea. Great, let's move on. We're going to see what the impact of A is and B is. Just to remind you, we're kind of comparing them to y equals sine x. And what we're going to do is we're going to put an A value in here and see what effect it has, and we're going to put a B value in there and see what effect it has. So we're going to start with A. So what we're going to do is we're going to graph these three functions right here. We'll put them in the same graph, and we'll see what they look like. So first of all, let's set this up. Let's put 1 right here, and we'll put 2 up here. I know you might be saying 2, that didn't happen last time. Well, there's a little hint of what's going to happen today. Let's go over 1, 2, 3 steps, and we'll put pi over 2, and then we'll go over 3 more, 1, 2, 3, and we'll put pi, 3 more, 1, 2, 3, and we'll put 3 pi over 2. If you look back to last day, we did this same sort of thing last day. Maybe I should have set this up before I started the video. Anyway, this would be negative 2 pi, this would be negative 3 pi over 2, this would be negative pi, and this would be negative pi over 2. Okay, here we go. If you forget what that graph looks like, I'll show you right now in my favorite, Desmos. So remember, it goes through 0, 0. At pi over 2, it's up at 1, and at pi, it's down at 0. Then at 3 pi over 2, it goes to negative 1, and at 2 pi, it's back to 0. Think you can remember that? I think we can do it. So we have 0, 0. At pi over 2, it's at 1. At pi, it's back at 0. At 3 pi over 2, it's at negative 1. And at 2 pi, it's back to 0. So it's like this. And it continues here. At negative pi over 2, it's down here. At pi, it's at 0. At negative 3 pi over 2, it's at 1. And at negative 2 pi, it's back to 0. So this would be our complete sine graph, y equals sine x. Okay, now let's see what happens when we graph y equals 2 sine x. So I'll go back to Desmos. I've already got it ready for us here. Ready? Here it comes. Boom. What happened? Well, you can see, if we look at the period, what's the period of the initial one? Right? What's the period of this? We learned last time that it starts to repeat after 2 pi, right? If you compare this point and this point, it's the same position of the graph, it's 2 pi. Now, what's the period of this one? It's still 2 pi. Up, down, we're back at the same point right here. So no impact on period. How about amplitude? Well, in our initial one, y equals sine x, the amplitude was 1. Now the amplitude is 2. This is the big difference here, is that rather than going up to 1 and down to negative 1, you're going to be going up to 2 and down to negative 2. So we can do that very quickly. So it starts at the same point, it goes up to 2 this time, then back to 0, and down to negative 2, and then back to 0. Period stays the same, amplitude is twice as much. Down to -2, to 0, up to +2, back to 0. So I'm thinking you can probably guess what's going to happen in the last case when we put 0.5 in here. So maybe I'll turn off this one so it doesn't get too busy and turn on this one, and you can see, look at the period, stays exactly the same, right? It's going from here to right there. It's still 2 pi, same period, but the amplitude now is only half as much. It goes up to 0.5, down to -0.5. Starts at 0, 0, goes up to 0.5, 0, 0, down to -0.5, and up to here. And down to -0.5, 0, 0, up to +0.5, down to 0. And of course I should have arrows on all these because they go on and on forever. There you go. So what's the impact of A? Basically what A does is it changes the amplitude. And what you might also notice is, what's the amplitude of the red one? The red one's amplitude is 1. What was the A value in that case? 1, right? There's a 1 right there. What's the amplitude of the green one? The amplitude is 2. What's the A value? 2. What's the amplitude of the blue one? Half. What's the A value? Half. Oh, so this is a very easy way to figure out the amplitude if you just have the formula. What the amplitude is equal to is A. What are these bars around it? Have we seen these before? I'm hoping we have. It means absolute value. So what absolute value bars do, if you don't remember, it's a pretty simple concept. If you have a positive number in the absolute value bars, it does nothing. It just stays the same. But if you have a negative value in the absolute value bars, it makes it positive. Okay? Basically what absolute values are asking you is the distance something is from 0 on a number line. How far is 5 from 0 on a number line? 5. How far is -5 from 0 on a number line? 5. So amplitude is always positive. Okay, now we're going to look at the impact of B. So we're going to start by graphing the exact same thing we did up here, which maybe is a little silly. I think what I'll do is I'll take time out here and set it up now. Okay, there we go. I've set up the graph and I've actually graphed the first one, y equals sine x. I did it in red again just to match the one we did above. So now what we're going to do is we're going to put, for the b value, we're going to put 2 in here and we're going to see what happens. So off to Desmos we go, we get rid of this one, here we go, y equals sine 2x. So we want to look at the same two things, amplitude and period. Which one stays the same? The amplitude stays the same. See, it's going just as high. It's only going up to 1, it's only going down to -1. So the amplitude's the same. But what happens to the period this time? Rather than the period, remember with the original, the period was 2 pi. It went all the way to 2 pi before it repeated. With this black one, how long does it take till it starts repeating? It's repeating after pi. Okay, so it's half as much. It's cut the period down in 2. So at pi over 2, this thing's already gone up and back down. So what we need to do is we need to go halfway between this point and pi over 2. So that'd be right here. And that's where it hits its maximum. Then it comes down through here, go halfway between here and here, which is here, and it goes down to -1. Then it goes through pi, halfway between here and here is up here, back through 3 pi over 2, halfway between here and here is down there, and then back to there. So a lot of up and down here. Of course, if your period is smaller, you're going to fit more cycles in, aren't you? And same here, halfway, so down to here. Hopefully I don't have to talk about this too much and you understand what I'm doing. Up to here and then down to there. There we go. Amplitude is the same. Period has been cut in half. And again, I bet you can guess what's going to happen with the last one. Y equals sine half x, or 0.5x. Let's check it out. There's the original. Here's the new one. Wow, what's the period of this one? You can't even see the whole thing. By the time we get to 2 pi, we've only gone up and down. We still have to go down and up. So the period's not going to be 2 pi, it's going to be twice as much. I can move it over so you can see. There's the point right there, 4 pi. The period is actually 4 pi. What's the amplitude? Amplitude is still 1. The highest point it goes is 1. Here's the midline, and it goes up to 1. So, okay, it hits its maximum at pi. So it starts here, maximum at pi, and then back to the midline here. So its minimum is going to be at -pi, and back up here. and that's it. Same amplitude, but the period has been increased. And those are all our graphs there. So what is the impact of B? It changes the period. Now, do we have a formula for that? Absolutely we do. So back here we go, down to period. Hate how it disappears all the time. There it is. Period equals, I have no idea. Actually, I think I do know why that line's there, but ignore it. Those are absolute value signs though. So the period is equal to 2 pi over b if you're talking about radians, and I believe in our work today we'll only be talking about radians. If you are talking about degrees, I guess I should have a degree sign there, 360 degrees, then you would do 360 degrees divided by the absolute value of b. So again, whatever your b value is, whether it's positive or negative, the absolute value signs will make it positive. Alright, with that in mind, let's go, maybe I'll just write that right here, period equals 2 pi over the absolute value of b. Great, determine the amplitude and the period for the following functions. And then suddenly it says absolute value of a there. I do not know why it says that there. Okay, for this one, remember to get the amplitude, all you had to do, well, you have to do exactly what I just erased, it's equal to the absolute value of a. So to get the amplitude, amp I'll say, you take the absolute value of 2/3, and the absolute value of 2/3 is 2/3. Done. To get the period, you do 2 pi divided by the absolute value of b, and the b value in this case is 6. Well, the absolute value of 6 is just 6, and 2 pi over 6, you can put that in lowest terms by dividing top and bottom by 2, you get pi over 3. Now to me that's an awesome answer, perfect. In your book for some reason they also want you to switch it into a decimal, so you do 3.14 divided by 3 and you'd get an approximate answer. I mean, it's pretty darn close, but the approximate answer would be 1.5, right? 3.14 divided by 3 is 1.45 or something like that, and it rounds up to 1.5. So there's your period, either one of those ones. In this one, the amplitude is equal to the absolute value of the a value. What's the a value? -2. So the absolute value of -2, what does that mean the amplitude is? 2. The period is equal to 2 pi over the absolute value of b, so that's 2 pi over the absolute value of -0.2, which means 2 pi over, what's the absolute value of -0.2? Just 0.2. If you divide 2 by 0.2, you're going to get 10 pi. And again, if you want to change it to a decimal, 10 times 3.14 is 31.4. There's your period. Okay, what's the amplitude and the period of this sinusoidal function? Period we can get, amplitude we can get pretty easily here. Remember, it's from the midline to the highest point, or the midline to the lowest point. I think this is your midline right here, isn't it? So what's the distance from the midline to the highest point? What's that distance right there? 1. Or what's the distance from the midline down to this minimum point? 1 as well. So amplitude is definitely equal to 1. The other way you could do it is you could take that maximum amount, which is 1, subtract the minimum amount, which is -1, and divide by 2. 1 take away -1 is 2, divide by 2 equals 1. Okay, what's the period of this one? Well, you can't actually see the whole cycle, can you? You can see it come up, you can see it come down, now it's going to have to come down, and it's going to have to come back up. Where's it going to come back up? Well, this is the halfway point, isn't it? So it's going to be back up here at 1. Oh, the period is also 1. Amplitude 1, period 1. What's the equation? Now be careful. What people often do with this is they say, okay, y equals the a value, which is 1, so you don't even need to put it, sine, maybe I'll just put it in there just to make sure, 1, but you don't even need to put it, sine, and then they say, okay, and then 1x, because the period here is, but that's not true. That's not the b value, that's the period. So I'm going to erase that. Are you confused what I'm talking about? Let me write down this formula again. Period equals 2 pi over the absolute value of b. Now, what's this 1 number right here? That's not b, that's the period. So 1, since the period's 1, equals 2 pi over b. Just ignore the absolute values when you solve this, it's fine. And you have to solve this equation. Now, how are you going to solve it? Well, I don't like this fraction. I want to get rid of the denominator. So why don't I multiply both sides by b? because if I multiply this side by b, what happens to the b's? They cancel. B times 1 is b, so I get b equals 2 pi. There you go. That's my b value. So you should have y equals 1 sine 2 pi, that's my b value, x. And I would put this in brackets. And there's the equation. Last question here. What's the value of the function when x equals 0.88? You could plug 0.88 in here and then multiply it by pi and multiply it by 2 and then take sine of that. That will work. The other way you could do it is you could graph this. Why don't we do that very quickly in Desmos? 2 pi x. Oh, watch this. This is so cool. Turn this off. Go to this one. I want it to be 2 pi x, right? Turn that one off too. I type in here p I, oh my gosh, Desmos is just unbelievable. I love this thing. And what we want to know is what's the value of the function when x equals 0.88. So you know what to do. Put x equals 0.88. You get this line. We want to know where they cross. They cross right here when the y value is negative 0.685. So we write that down. Negative 0.685, and we are done. Okay, so either use the graphing method or plug that amount right in there and use a calculator. That'll also work. All right, thank you.
I was a free man in Paris. I felt unfettered and alive. There was nobody calling me up for favors, and no one's future to decide. You know I